I'm going to jump back to the resource pack directory, and I'm going to go ahead and open up the 17th step, and this is called parser and table output as two functions. Let's go ahead and copy this code and paste it over the code that's currently in the test.php file and save it. I'm going to scroll up to the top here. Now in this file, we've done a couple of things differently. First of all, we've separated the logic out into two separate functions. One is called parseDataFile, and this takes care of taking a text file and making it an array that we can use later. The second function is called outputAsTable, and it takes an array of items and then it loops through, I'm going to scroll down here, and generates a table out of it. Now, if you're just scanning this code, you also notice that there's been some significant changes to the actual logic. And the reason for this is that we've generalized each of these functions to be able to work with multiple types of data. Our previous code expected a certain type of data. So if we go ahead and take a look at it, it's the 16th step here. You see that as we loop through each item in the array that was generated from the data.txt file, we expect a name, a birth year, favorite band, and shoe size to come out of that data. Well, what if we want to use this same functionality for a different type of data that has more or less data columns, that has different types of data that we can't anticipate right now? Well, it's not that hard to generalize our code in order to work with that. And if we can do it, it will make our code much more powerful. So let's go ahead and take a look at how we're going to do that. I'm going to scroll back up to the top. So when we improved our random text generator from before, what we did first was we isolated the parts of our data that were unique to our situation. Once we had that data, it gave us a good clue as to how we could structure the code in order to work with different situations. So as you can see, this parseData file actually takes several parameters here. Let's go ahead and scroll down to where we're implementing this and see how that works. So our first piece of unique data is the actual text file that our data is coming from. Now, when we created our function in the last step, we generalized it enough to allow for different text files to be supplied to the function, but it still would require a certain data structure. The next pieces of data that are specific to our situation here are the column names. So we're creating an array here called array labels, and we're assigning it an array that includes the label names for all of the columns inside of our data file. For us, that's name, birth year, favorite band, and shoe size. Believe it or not, these two pieces of data are enough to be able to generalize our code to work with any data structure. As you can see, our next step in the code here is running parseDataFile, and we pass it the name of the data file as well as the labels for our columns. Let's go ahead and jump up to this function and see how it works. So here's our parseDataFile function. We have our data file parameter here, our array labels parameter, and then we have a couple of additional parameters that we're not passing now in our function, but that we want to leave open to allow for different structures of data. The first is the record divider. Because we're using a CVS or a comma-separated value file, every record will be divided by a new line, which is this character here. Every piece of data is separated by a comma, and so we're setting the data divider to be a comma by default. So again, if you remember from when we talked about functions, these two parameters are optional because we're setting defaults for them. In our call right now, because we're not setting these parameters explicitly, record divider will be set to new line, and data divider will be set to a comma. Now the first part of this code is identical. We're starting an output buffer, we're including our data file, we're pulling it into a string, and then we're ending our output buffer. This next step is nearly identical to our previous code. We're using explode in order to separate our data file into separate records based on the divider. In our previous code, we assumed that the new line would be a divider, but this code generalizes it to allow for different dividers. So we're pulling in record divider as the first parameter to pass to explode. In our situation here, that's still going to be a new line. The second parameter is the data that we pulled in from our data file here. And once we have our data array, we need to loop through each one and pull out the individual pieces of data. So this first line here is similar to our previous code, but we're using different variable names. If we jump back to the 16th step, you see that we use for each people data array as person string. But in our new code, I'm going to jump back to our new code here, we're looping through data array as string. Now the reason for this is that even though the data that we're working with now has to do with people, we're generalizing this to work with any type of data. So we're renaming our variables to be reflective of that change. So instead of person string, it's just string. In our next step, we're dividing our record into individual pieces of data. Now in our previous code, we assumed that it was a comma. In this case, we're allowing for any divider, but because we haven't supplied a specific divider, it will default to a comma. Now if we look at our previous code from here, I'm just going to jump back over to it. What we did was we took each item in the array and we assigned it to an individual string that was named according to the data that we were expecting in this part of the array. So we have name, birth year, favorite band, and so on. In our new code, we don't know for sure what the specific data is in any part of this array. So we're going to deal with it differently. I'm going to jump back to that code here. And so what we're doing is looping through each item, and we're separating out the key and the value. So this key is going to be a number, and the value is going to be the data itself. Now the reason why we need this key will become clear in this next line. This line is tricky to read, but let's go ahead and work our way out from the middle. So the first is that we're taking the key of array labels here. So this key, the first time for each runs, will be 0, which if you remember, is the first key in an array. And so what we're doing here is pulling out an item from array labels that matches up with this key. Now again, array labels was passed to this function and contained an array of labels for each array item. In this case, it was information like name, shoe size, and favorite band. And so in this case, let's go ahead and scroll down and look at our list of array labels. The first item is going to be name here. And let's go ahead and scroll back up. So array label 0 will be name. This next part, which contains that name, is the item array that will eventually belong to our full array of data. So if you remember, what we're doing is we're taking every line inside of our CVS file and we're turning it into an array, and then that array of data items will belong to a bigger array that includes an item for every record inside of our data file. So what we're saying here is that we're starting a new item array. The key is going to be the word name, which comes from our array labels, and then the value of it is going to be a trimmed version of the value of the data.